Hey everybody, welcome to chapter number 2. We're going to be discussing rational numbers today. Don't worry about any of this. You do not have to take a look at that. Don't worry about this. We've already discussed our chapter 1 test. If you have any questions on your test, please let me know so we can talk a little bit further, all right? So if not, let's get going with number 2, chapter 2. 5 warm-ups, so I want you to do these 5 warm-ups. So please pause now and do these. Again, try not to use a calculator. All right, so like I said, you're not going to be able to use a calculator on your test, but I can give you the answers to these. 36 divided by 3, your answer is 12. 144 divided by 6, your answer is 24. Number 3, your answer is 68 divided by 17. You will get 4. Number 4, 345 divided by 115. Your answer is 3. And the last but not least, 1024 divided by 64. Your answer is 16. All right, today we are going to be doing quite a bit of dividing because we're going to be changing different numbers because we're going to be discussing rational numbers. All right, so I hope you are excited like I am. Here we go. Talking about rational numbers. First thing is, what is a rational number? So a rational number, I want you to pause the video and write this down. What is a rational number? Here it is. So a rational number is any number that can be written as a fraction, n over d. N over d, that's just two variables where n and d are integers and d can't be 0. Okay, and the reason d cannot be 0, if you think about a number 16 and put it over 0, that is impossible. It's called undefined. Okay, if you type that into your calculator, 16 divided by 0, it will come back domain error, syntax error, yada, 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 a lot of errors. Okay, but it's undefined because you can't find that answer. There's no, I can't put that on a graph. I can't put that on a number line. There is no answer for 16 divided by 0. Okay, so that's why d cannot be equal to 0. But there are, all numbers can be written as a fraction. Remember the number 7. What is 7 as a fraction? 7 over 1 has a denominator of 1. 64 as a fraction. 64 over 1. All right. So those are rational numbers, but any number that can be written as a fraction is known as a rational number. All right. Next is going to be relatively prime. Get used to this, relatively prime, because we're going to be dealing with fractions, and you're going to have to find things that are relatively prime. So pause the video, write this down. All right. So we have numbers. Relatively prime is numbers that have no common factors other than 1. Okay, so two numbers, an example of relatively prime, number 8 and 9. These are relatively prime numbers. Okay, why? Because neither one of them have a common factor other than 1. Okay. Neither one of those numbers are prime, but because there are no common factors between 8 and 9, those are relatively prime. If you look at a fraction that's reduced completely, so in simplest form, those numbers are also relatively prime because the goal of simplifying fractions is to make the numerator and the denominator relatively prime to where not another number can divide each of those evenly. All right, so that's enough talking about it. Now let's try a problem in just a moment. I know you got excited. I got you. Okay, so if you look at simplifying fractions, you may have done this before. Look at 12/15 and 4/5. Those down here, okay, as you can see down below, okay, those are going to be essentially the exact same. If you look at it and break it up into different shades, they are the exact same shaded. Okay, the same area is shaded. Okay, and how you can simplify this is by taking 12/15 and there's a common factor between 12 and 15 besides 1, and that is going to be 3. What's a number that can divide both evenly into 12 and 15? It's going to be 3, and you would get 4/5. So 12/15 divided down is 4/5. All right? So let's try a couple problems. What I want you to do is think of a number that goes into both the numerator and the denominator, the top number and the bottom number evenly, to reduce them down as much as possible. So if we look at this, 16 over 80 and negative 12 over 17, I want to see if you can simplify them as much as possible. Pause and give it a shot. All right, so if you look at this, 16 over 80, what's a number that can go into both 16 and 80? Well, it is going to be, you can divide both of them by 2. Okay, 16 and 80, that's going to be 8 over 40. Now, is that all I can divide into, or am I done? Or is this in simplest form? No, I can take 8 over 40 and divide them by 2 again. Okay, 8 and 40 have a common denominator, a common factor of 2, and you get 4 over 20. Again, 4 and 20, we can divide by 2, and my answer would be 2 over 10. Am I done again? No, I can divide by 2 one more time, and my answer is going to be 1/5. Now, you may be looking at that as, whew, that's a lot of steps. Wow, I can't believe I did that many steps. You can take, if I look at 16 and 80, what you want to do is try to see the biggest common factor. The biggest common factor that 16 and 80 would have. A big common factor that both of them would have, okay? You could start off with taking 8 into both of them. Divide both of these by 8. And you will get 2 over 10. And notice again that you can divide each of those by 2. And you will get 1/5. There are many different ways. You could have started dividing by 4. Heck, if you would have known that 16 and 80 have the common factor of 16, you would have broke it down to 1/5 right away. I do not care how many steps it takes you. Break it. If you need to break it down slowly, break it down slowly. If you want to break it down in big chunks, break it down in big chunks. Whatever makes your brain think better, do so. Okay? But just know that if you're stuck anywhere, start with small numbers. Start with 2, start with 3, start with 4. Okay? And then go from there and see how that works. All right? Next. Negative 12 over 17. Is there a number that goes into both negative 12 and 17? That's not 1. No, there is not a number that goes into it. There is not a number that goes into negative 12 and 17. It was a trick question. Oh man, I'm tricky. Okay, and you get, that's your answer. Okay, so the top one is 1/5. The bottom one is negative 12 over 17. Trick question. Oh, Mr. Sheeman, get some good. All right. Next one. All right, so decimals that terminate or repeat are rational numbers. Okay, so if there's a decimal, something like 1/3, 1/3 repeats. It's equal to 1.3 repeating. It goes 0.333333333333333333. Oh, whew, a lot of threes. Okay, that keeps repeating. Because it repeats, it is a rational number. A terminating decimal is something that terminates. It ends, so something like 0.25. 0.143. Those are terminating decimals because they end. All right? Those are also rational numbers. When you're writing a terminating decimal, identify the place value of the digit farthest to the right. Then write all of the digits after the decimal point as the numerator with the place value as the denominator. What in the world does that mean? Well, if I look at the point of, let's say, 0.25, okay, I can write it as a fraction with 0.25. You go 25 over 100. The reason why I do that is because that 5 is in the hundredths place, and that's why it goes underneath. Okay, hundredths place, it goes because that 5 is in the hundredths place, it goes over 100. If I give you 0.076, okay, what place value is this 6 in? Thousandths. It's in the thousandths place, so I would take this and I would take 76 over 1,000. Now, of course, we can simplify these two, and we would simplify those two, but start with writing a fraction and then simplify it from there. Okay? Okay. Okay, so if you look at this, this is a description of a terminating decimal right here. And it goes and it stops. This is that number written as a fraction. It's over 10 because that 2 is in the tenths place. Okay? 0.16, repeating, that's a decimal. That is the exact fraction as 1/6. And we'll talk about how we came up with 1/6 because this is in simplest form, but we would need to find a place to start that we would need a place to start with that before we got to 1/6. So you don't just take 1/6 all the time. All right, let's try. Okay, so write each decimal as a fraction in simplest form. So you are going to start again. What place value is that last digit? What place value is the 7? What place value is the 6? What place value is the 2? Whatever place value that is in, that's the number you put it over. So if it's in the tenths place, you put it that number, those digits over 10. Hundredths place, those digits over 100. Thousands place, digits over 1,000. 10,000 over 10,000, so on and so forth. So give these three a shot and see what you come up with. All right. So the very first one, how would I start? Well, that 7 is in the hundredths place value, so we would take 37 over 100. Okay, 37 over 100. We need to simplify that down. So is there a number that goes into both 37 and 100? No, there is not. No, there is not. Okay, so what I do is I leave it as that fraction. All right, just like that. Next, 30.036. That is 36 thousandths. Place value is the thousandth, so you take 36 over 1,000. Simplify this down as much as possible. As I do that, I can see in my head that each of those have a common factor of 4. So you take 36 divided by 4, you get 9. 1,000 divided by 4, you get 250. Can you divide any more than that? Okay, so if you look at 9, factors of 9 and factors of 250, can you divide it any more? No, you can't. You're all done there. Okay, you're all done. Donezo. Okay, so 9 over 250 is your answer. Okay, 0.62, what place value is that last 2 in? Thousandths. Thousandths place value. So as you write this in a fraction, it's 622 over 1,000. Is there a number that goes into both 622 and 1,000 that you know of? Well, I don't know any big numbers, but I do know for a fact that I can divide each of these by 2. Why? Because they're even numbers. Okay, even numbers I know can be divided by 2. 622 divided by 2 is going to be 311, 311. 1,000 divided by 2 is going to be 500. Is there a number that goes into 311 and 500? Not that I know of. No, I don't know. Okay, so right there, you could try it, but there isn't another number. 311 over 500. Whew. How'd those three go? Good? Bad? So-so? All right. Awesome. Give the person next to you a high five, just because it's a fantastic day to do math. Gotta love those days. All right. Now what we are going to be doing is writing a decimal as a fraction. Okay, or sorry, a fraction as a decimal, going the other way. We just wrote a decimal as a fraction, now we're going backwards. So we're doing the circle. The circle of life. Circle. First we did fractions into decimals, now we're doing decimals into fractions. Let's do a few. Now, when you look at the denominator, numerator, and a denominator, if I give you a numerator of 4, denominator of 11, that denominator goes on the outside, numerator goes on the inside. I like to call this our house. Okay, that's our beautiful house. The numerator is the lucky one, gets protected by the house because they are on top. The top number is better. I'm just going to go with that. You want the top number, so that gets plugged into underneath our house. The denominator is not as fortunate. It goes outside our house. Denominator goes outside, numerator goes inside. It kind of does a little, if you can see it, kind of shifts. You can see this numerator going down, denominator coming out. Okay? All right, let's try a couple. All right, so write this fraction as a decimal. Again, remember what you do as a numerator, remember what you do as a denominator. What do you do with each? Okay? So, as you do these, I'm going to show you this very first one. Okay, numerator goes underneath, so 11 goes underneath. Denominator goes outside, 9 into 11. Okay, then you just divide it. How many times does 9 go into 11? One time. 1 times 9 is 9, minus 9, you get 2. Notice, I have a remainder. I don't like remainders. We're not going to have any remainders. So what we do is we put a point here, okay, and a 0. We're going to add a 0. Now, the key is when I put a decimal there underneath the house, I need to put a decimal underneath on the roof. I call that the roof. We'll call that the roof. Okay, so that decimal goes underneath that division sign. It also goes on top. Okay, and notice how it goes directly on top. We need to line those up. So I then bring down my 0. How many times does 9 go into 20? 2 times. 2 times 9, 18, minus 2. Bring down another 0. Uh-oh. Look at this. Does anybody see a pattern that's going to be happening? Okay, when you notice that, that would be another 2, 18. Look at that. We down to 0, bring it down. We don't need to do this forever because it would keep going on and on and on and on forever. So we know the pattern repeats. If it repeats, do you remember what to do? As it repeats, there's a bar that goes in front of that first 2 over all the digits that repeat. So 1.2 repeating. Your answer would look something like that. Something like that. Okay? Something like that. Next 2, I'm going to have you try by yourself. I want you to write these 2 fractions down. You don't need to rewrite the directions because directions should already have been written down. But 7/20 and 5/6, I want you to try those 2. These are the last note of the day. Give these a shot. All right, so we have 7/20, we have 5/6. What goes underneath our house? What goes on top of our house? Well, denominator goes outside, numerator goes inside. Now, how many times does 20 go into 7? 0 times. We can't put 20 into 7. Okay? However, are we done? No, because if I do this, I still have a remainder of 7. I don't want any remainders. No more remainders. So what do? Put our decimal with a 0. Because I put a decimal here, I put it right on top. And I bring down my 0. How many times does 20 go into 70? 3 times. 3 times 20 is 60. Subtract. We get 10. I have a remainder. I'm not done. Bring down another 0. How many times does 20 go into 100? That is 5 times. 5 times 20 is 100. And my remainder is what? 0. Okay, so when I have a remainder of 0, I've found my answer. Or, ooh, Mr. Sheeman, you almost forgot about this. Or if it repeats, don't forget, if it repeats, you're also done. But this one is a terminating decimal because it ends. 0.35 is our answer. Okay, next, 5/6. If you didn't pause to finish, if you wanted to go through that first one and you didn't pause, I want you to pause now and try this 5/6. All right, here we go. So 5/6, again, what goes on the inside, what goes on the outside? 6 on the outside, 5 on the inside, and I'm talking about inside and outside my house, this wonderful piece of shelter that it gives. Okay, so now how many times does 6 go into 5? 0 times, can't go in there. Okay, so now what do? Well, put a decimal here and a 0. Decimal goes there, so it needs to go on top, like that. Okay, so we get 50. How many times does 6 go into 50? It goes in there. How many times? 8 times. 8 times 6 is 48. 8 times 6 is 48. 8 times 6, 48. Put another 0. How many times does 6 go into 20? 3 times. 18 minus 2. Bring down a 0. Uh-oh, Mr. Sheeman found a pattern. Okay, notice this. I'd put another 18, and I'd get 2 again. So, because I'm finding this pattern, what do? Well, first I stop what I'm doing. Red light, stop. Okay, and how do I write a repeating decimal? That 3 repeats. So my answer is 0.83 repeating. Now, a lot of you may be asking, Mr. Sheeman, do we really need this 0? Do I need that 0? I'm flexible. I could go either way. If you want to put the 0 in, that's fine. If you don't want to, that's fine. Whatever you want to do, as long as you know where that decimal sits. Now, if you're not putting a 0 and the decimal is all wackadoo, it's going crazy, it's never in the right spot, then I'm going to suggest you put that 0. But if you know that is not... you don't need that 0 and you're putting the decimal in the right spot, I'm okay with it. All right? All right, rational numbers. Got done with Chapter 2, Lesson 1. We started Chapter 2. I hope you're excited because this chapter is all about rational numbers. All right? I hope you enjoyed it. Have a great day. Bye!